Hello, this video is about LoRA training of clothes. Okay, the principles applied in clothes training is similar to person or any type of object in general with minor differences. Now, what I want to train is, for example, a set of clothes. For example, this clothes which are on a mannequin. So this is a plastic mannequin, and I want to produce results something like this. Okay, so we had a mannequin before. This is a mannequin. And this is the result. So our mannequin is removed and the clothes are being dressed on another person, for example. Another subject that I will train is a jeans. I will train both jeans and okay, this is the jeans that I'm training. Okay, so this is a jeans on a person and I want to train it and see how it can be dressed on another person, like this, for example. Okay. So I will train two subjects in the same LoRA and discuss the differences between using regularization and without using regularization and some recommendations regarding this training process. So the first step is to prepare the data. Assume, for example, that we have jeans and a blue dress. So I want to train a LoRA for this dress and for this jeans, for example. Okay. So we should scrap some data. For example, if we have a clothes store, we can take pictures of a mannequin wearing this dress from different angles. Okay, now it's also possible to use real people in the training. Now it's very important to note that LoRA will learn everything in the pictures. So it will learn the mannequin and the dress as well, but if we repeat the dress more often, it will learn the dress better and faster. And it's more difficult to learn the facial features because they are more difficult than dress. So what we first do is to prepare the data. For example, this data we need to use Photoshop, for example. If I have a set of pictures like this, we can cut the pictures, for instance, like this, for example. We would center it and use something like unlock here, remove background. So the background is removed. I would press C. To crop, I would use the ratio 2:3. Okay, and center the object that I want to learn and press enter. Okay, now I can press Ctrl Alt Shift W to save this image. We would choose a good quality and export and save the data. So we apply this for each of the pictures. After this, we can also, because we only have 4 pictures, for example, we need to augment this data. What I would do is to create 1 by 1, size 1 by 1, and crop the head, for example, like this, because I don't want the head to appear in all the pictures. If the head appears in all the pictures, it will learn the head faster. So I would generate more pictures by in this methodology. So by cropping, it's also possible to rotate. Okay, the rotation can also augment the data. Okay, and help the model to learn more poses. And this is just an example of data preparation. So assume that we have prepared the data. We have 4 pictures of this type. These are 2 by 3, or 2 by 3, not 3 by 2, size, dimension. Now these are square images. Now, like I said, it's actually better not to show the face in the pictures, but my data set is very small and the picture quality is limited. So then we would go to PIRMI, for example. Now, the more pictures we have, the better. In my case, I don't have many pictures. So here we would use 512 by 512. So PIRMI is used, for example, to prepare the data to get something like 512 by 512, 512 by 768, etc. So I would crop the images down to this size, then save as, and store them in this location. Now next, I would go to the second data set, which is like this. I want this to be 512 by 768. So I would save this as well, extract these and combine them in one folder. So once we combine them in one folder, we can start the captioning. So I'm only going to use 12 images. Like I've said, it's better to increase the number of images by having rotations, stuff like this, and reduce the number of images where the face actually appears, because I don't want to learn the mannequin very quickly. I don't want to learn it at all if possible. We apply the same thing for the second data set for the genes. We get something like this, for example. Now we can see that in the genes case, we only show the face twice. Now this is a real person. Now because the face only appears twice, it will be learned. It won't be learned in comparison to the genes, which appears in all the pictures. So my subject must appear in all the pictures, while everything else must not. For example, if I have a white shirt in all of the pictures, it will also learn the white shirt as well. Okay. Now we copy this data, for example. We put it in the training folders. Now, like I've said in the first video, we have a class folder, image folder, model folder. In the image folder, this is where we locate, where we place the folders that we want. Now we can use number of steps, for example, 10. Let's assume that we want to name our target XYZ blue jeans. Okay, we place the pictures here. Now then we train another subject. Okay, now we can train multiple subjects in the same LoRA by having a folder for each of them. We could also use different number of steps. For example, we could use 5 or 8, or use even 10, XYZ blue dress. XYZ blue dress, XYZ blue jeans, for example, because that is slightly more meaningful. The second data set, for example, is here. Now, this is my second data set. I place it here. Large icons. So in general, I don't recommend training more than one subject in the same LoRA, because we would have less control over the parameters. And sometimes a certain subject, for example, this subject could require 1,000 steps to train, while this subject could require 1,500 steps to train, for instance. So it will not be fair to have the two subjects in the same LoRA and expect them both to converge properly using the same number of steps. Okay, so it's better to actually train each subject in a different LoRA. But I want, in this example, to show a case where we can actually train more than one subject. So normally, for example, in this picture, we only have two faces, so it will require less number of steps to train. So I can assume, for example, that we can use 8 steps or 8 repeats, 8 repeats per image. Here I would use 10 repeats. Now, why we don't use something like 40, for example? Now, you can test this, and you will see that if we increase the number of steps to 20 or 40 or 30, it will converge way much faster, and we might skip the right epoch. So it's better to actually reduce the number of steps and increase the number of epochs so that we know which is the best epoch to use. Okay, so always use a lower number of steps. Now for training subjects such as a clothes, for instance, now the principle is the same. Okay, LoRA will learn everything that repeats in the image. So it will learn this pattern. It will learn blue jeans with torn parts, for example. So that which repeats, it will be learned, but it will also learn everything else. For example, it will learn the face, but depending on the number of steps, it will learn the face much slower than the jeans, for example. Now, on the other hand, when it comes to the dress, now we have more faces here, so it will learn the faces much faster. So, like I've said, it's recommended not to have too many faces in the dress, or blur them, the faces. You can actually blur them, and LoRA will still be able to learn that this is a dress that is dressed by a woman, for example, or by a person, because Stable Diffusion has already learned the concept in general, which is the concept of clothes and people. Now, it is possible to use classification and not to use regularization set. Now, what regularization set will help is it will reduce the effect of the person, for example. So what kind of a classification image I would use for in this case? We have to use people wearing dresses, okay? So I don't want to use to learn this concept, the concept of the woman. So my classification image, for example, it should be ideally a woman, okay, a woman wearing a dress, okay. So because I don't want to learn that face that exists in my data set, so I would use new faces in the data set. So it will basically learn some of these features. And it's also good to have for the classification images to actually be of good quality, because the better the classification images they are, it's more likely that the LoRA will be better as well. So it's also possible to use images with deformation. That's not very important because it will not learn these images as good as it will learn the LoRA. So the purpose of the regularization is to disrupt the learning process. So assume that we will be using regularization. We can also, I will test regularization and without regularization and see the difference. Now it's possible to learn the concepts in both cases. Okay. So now our data set is ready. Now we can launch the LoRA, the Kohya SS. We can launch the Kohya SS graphical user interface so that we can start the training process. The first thing that we would do is to caption. We would go to utilities, captioning. I will use WD14 captioning because it's used more often in the stable diffusion. Checkpoint. Now we choose the folders that we want to caption. The first thing is the blue jeans. I would select. Now, because we have multiple concepts, it's better to actually add a trigger word because each subject should have a different trigger word. The trigger word could also be considered the folder name itself. Okay, now if I have one subject, it's not really that important to have the trigger word because the instance prompt name is the trigger word itself. So for example, XYZ blue jeans. Now I want the blue jeans, XYZ blue jeans. I would add comma. Now I should ideally remove everything that I want to be part of the LoRA. For example, blue jeans, for example, I don't want to say blue jeans. But if I want the jeans to actually to change the color, okay, it might be better to keep that inside the LoRA, okay, but it might not always work as we expect. For now, I will leave it as it is. Now, if I'm creating a character, we should actually remove one. Girl, solo, like I've said before, realistic. Please don't keep spaces between the images. Realistic, looking at viewer, etc. Anything that repeats the eye colors, for example, brown eyes, the hair color, black hair, for example. So anything that I want to be part of the LoRA, I should remove it from the desired and undesired tags. Now I can remove the tags later using a special software that can double check the tags and remove them. Okay, we will see this step. So we choose and then we caption the images. We check here and wait for the captioning to complete. Now the captioning is complete. And now I should review the captions because, for example, there's torn pants, torn jeans. I don't want these to be part of the captions because these are part of the LoRA. Okay. Because I don't want to repeat these words when I prompt. Okay. Secondly, we would choose the second dataset, which is the XYZ blue dress. Now we just change the blue dress, and we caption the second dataset as well, and wait. So once the captioning is complete, I can go to a special software such as Borrow, for example, Borrow Dataset Manager Tag Manager. Now, this software has some issues, some problems, but it's still useful. Now, I would go to File, Load Folder. Now, I'll choose Blue Jeans, for example, folder, select. I can see here in my dataset. Now, what I don't want is these torn parts, pants, and torn jeans, so I can remove them from all of the images at the same time by going to all tags. Why do I want to remove them? Because I want the torn part to be part of the LoRA, okay? So when I remove them, it's better. I can keep them as well, but it's better to remove them. I want to remove torn and keep XYZ blue jean, XY blue jean, or let's rename it and blue jeans, for example. Remove and add. I want to put at the top XYZ blue jeans. Okay, now if I come to each tag, we can say that XYZ blue jeans. Now, if I don't want to change the color of the clothes, I can also remove blue pants, for example. Okay, anything related to the character, I can remove it. For example, its color, blue pants, blue dress, etc. Now, however, if I want to change the color of the dress, it's preferable to keep the color inside the LoRA. Okay. Now, on the other hand, it's because I know this is a pant, so I can remove it. Jeans, for example, I can remove jeans. What else? I think it's fine like this, so we can press save. Now sometimes we get error here. If we don't get an error, that would be great. I would usually close and reopen because this software is not very stable. Now I need to load the second folder. The second folder, which is the blue dress. I would apply the same thing here. Check here, XYZ blue. Now there's a typo in the blue here, so we can correct it by removing it, then adding it once again at the top, XYZ blue dress. Okay, now it's added to the top. Now it's a blue dress. I can remove the blue dress actually because I know it's okay. I can also remove the dress because I don't want dress because I know it's a dress. I would keep blue dress if I want to change it to red, for example. But if I don't want to change it, it's better to actually remove blue dress because it's part of the LoRA as well. Now we look at it. It looks acceptable. We save all. Now our data set is ready. Now in my data set, now it's captioned and Brewing. So this is Brewing. So what we do in Brewing is actually remove the captions that belong to our subject. Okay, anything that relates to our subject should ideally be removed, but it's not necessarily. Okay, now captioning is always better than not captioning, and it's always good to actually remove the features that we want. Now the data set is ready. I can go once again to the LoRA. I can go to the LoRA tab. Please don't confuse LoRA with Dream Booth here. Now what we would do is choose, usually I use a configuration file to speed things up, or do the settings all over again. So configuration files can help us repeat the same thing without having to input each parameter every time. So what we would do is open, for example, and just load the configuration file. Now the model that I will use is Photon, for example. It's possible to use any kind of model, that's totally fine, from 1.5, etc. But Photon, for example, can give some really good photorealistic images, for example. So we would choose the checkpoint from this location. Then we check the folders. Now it's possible to run with the classification images and without. I think I will test for classification and without. Initially, I will run with regularization set. Now, why do we use regularization? Regularization is just like a disruption of the training process, like I've said before. Now, it's also possible not to use regularization. Let's test it without regularization first. XYZ clothes. Now, if I have one subject, I would name it related to that subject. I don't want to spend much time on this video. Now, parameters, I would use standard. I often actually use licorice, Locone, because I saw that it produces better results, but since most people use standard, I will use standard. Now, the only difference between Locone and the standard is just the convolution and the network rank. So in Locone, we would reduce the network rank to under 32, for example, use network alpha 4, convolution 4, 1. Now, for the standards, I would use basically the same settings. I will just now when I'm training a subject that has many images, for example, hundreds of images, I would use 128, and I would use lower alpha, for example, 64 or 32. Now, when we put that, if we are training a simple subject such as clothes, which has 10 images or 12 images, it's better to have 32 maximum. Okay, there is no need to have more than 32 network rank. Okay, we can use 32, 16, or 8. That would make the file size smaller, and I think that is much better. Too much freedom for the LoRa is not really that good, because having a larger network rank, it will help the model learn more features, but it can also make it overfit faster. Now, regarding the settings, I would use training batch 1 because my GPU is limited. Now, if we use more than one, it's recommended. Okay, it's okay to use more than one if you have a strong GPU. Regarding the epochs, usually we don't really need that many epochs. I will use 10 epochs because this is a simple subject of a clothes. So I will stop the training when I see it starting to overfit. Save every one epoch. Now the mixed precisions, I will keep it PF because I have RTX graphics card. Now the seed is very useful actually because it allows you to compare different models. So if I want to compare this model with another model, it's better to use the same seed. Okay, for example, I could also use this seed once again in Stable Diffusion to generate the images that were generated by the Kohya itself. So the seed is used actually in many locations in the Kohya, so it's really good to keep it. Now I would use the same default settings of cosine and learning rate. The cosine will start going down to 0. It's really useful. There's no need to change that. These things, they basically produce similar results. I tried different results and I've seen that cosine constant produce good results, and they are fast enough. They are faster than other factor. Some might work in better than others depending on the model and the data used. So there's no rule of thumb here. I would also use the optimizer Adam W8-bit, which is really fast enough and produces good results. It's very reliable. Now, if I used add a factor, for example, here, I need to put add a factor here as well. Now, I will keep the defaults, which are really good enough. Now, the maximum resolution in my dataset, it's 512 by 768. Now, usually, the Kohya will actually read this value from the dataset, so it's not really necessary to put it, but it's a good habit to actually put this data. Now, enable buckets when we have different pictures with different resolutions, such as in my case, because I have 512 by 768 and 512 by 512, so I would enable buckets. Now, there's a very important note about enabling buckets. I will mention it right here. Okay, network rank 32. We don't need more than 32, even with two subjects when it comes to clothes, because we only have a couple of images. In the advanced configuration, I would keep everything as it is. Now, I will keep clip skip 1 because it's a realistic model. Now, it's possible to use these methods. Okay. Color augmentation and flip augmentation. Now, if the colors of my subjects are not really that good, I might use this. It will add random saturation or random hue to the images. Okay, I could also use flip augmentation. What is flip augmentation? For example, when I look at this image, so sometimes it will learn it in this method. On the other hand, it will flip it horizontally. So it will learn like the same subject, but twice. Okay, not twice, but for example, in this epoch, it will learn it in this position. In the second epoch, it will learn it like in the opposite direction, for instance. So it will randomly flip the image horizontally. This is like an augmentation of the dataset itself. So it can be useful for images that are symmetrical. So if my subject is symmetrical, it would be okay to actually use the flipped augmentation. It might produce better results, even with people, for example, but this will make the training take slightly more time, so I won't use it. Okay, Now, one important thing I think is actually to have the image generate a prompt. So write this prompt. Literally always write it, because you really want to see the output of each epoch so that we know when to stop the training. For example, we don't really need to run for 10 epochs most of the time. Sometimes we only need to run for 3 epochs. So we stop the training. We don't need to continue training if the pictures start to overfit or become overcooked or broken. Okay. So what we would do is masterpiece, because we have 2 subjects, we should actually write what we want to display. XYZ blue dress, because if we don't put blue dress, it will come with something random because we have 2 subjects in the image. We make that prompt very simple negative. Now, if we remove this, we can see this is the default. So we write the same default basically. We just add the subject trigger word for our data set. Now we make the image 512 by 768 because I want to have something like a full body or a cowboy shot. Okay. Now once we are complete, okay, 10, like I've said, it changed to 9 without my intention. This is why it's very useful to actually review. Now regarding the folder name, now because I'm training a jeans, so we can actually put the class name as jeans, which is also a subclass of pants, for example, or a subclass of clothes. So a class name here would be clothes, for example, or just jeans, okay, or pants, for example, because pants is more general than jeans, for example. Now this class is also a cloth, but it's a dress. So the class name is actually dress, okay? So we should ideally put the class name dress, for example, here, and jeans in this location before starting the training. We can start the training and check the results. Okay, like I've said, this is a simple subject, so we might only need approximately 1,000 steps. This might differ from one subject to another, so we need to test to see actually how many steps we need. Okay, but usually we don't really need too many steps for a simple subject with a limited number of images. And now during the training, it's better to check the pictures from the model folder, sample folder. We can check the picture is generated. We can see that the dress looks like our model. Now we can see that the face here is not the mannequin's face, okay? It's just one girl, because the face does not repeat in all the images. In the second picture, okay, this looks more like our dress, but not that much because we have this extra. Now in the third epoch, we can see that this is our dress. So our LoRA has learned the model, but still the person who is in the picture is not a mannequin. So this looks good. Now in the fourth, however, now we can see that it looks more like a mannequin, starts to converge into a mannequin. So in the fifth epoch, we can see that this is some kind of overfitting because it has learned the mannequin. Okay. Now, like I've said, it's better to have only like 2 or 3 mannequins in the picture and cut the face. Okay, it's better to cut the face sometimes. So I would say that epoch 3 looks good enough, for example. Okay, now we can stop the training and hope that the genes were learned properly, because we could not see the genes in the same command. So I will stop the training. Now in the second model, I will use the same settings, but I will also include a regularization set to see the results with the regularization. It's always better to use with the regularization and without. Now I will use v1 reg and keep everything else the same. Just change the model name and add a classification. In my classification set, like I've said, I have a woman with dresses. Okay, and the genes inside the classification set should ideally not have torn jeans. So the classification, for example, I want to have something, for example, like yoga pants, for instance, okay, because it's different than the jeans. So it's better to have different jeans and different types of dresses. It's fine if some of the dresses are similar to some extent. For example, a torn jeans like this, I would actually remove it. That would be much better. Okay, because I don't want to have same jeans in the classification set. Okay, it's better to have different types of jeans, different types of pants than my training. Okay, that would be much better. Okay, the classification set can be different sizes, for example, 512, 768, 512 by 512. If there's a nudity, we should remove it, okay? Because we are training clothes, so we don't really need any type of nudes in the pictures. So once we are satisfied with the classification set, we can run the training again using the same settings. Okay, so we have a classification set, and this is the new model. We train the model. First thing, we see that the number of steps have doubled. With the regularization, this is a two-factor regularization. That means the number of steps will double. Now we could also check how many images are being loaded and how many subsets will be trained. Now with the regularization, the training will take a longer time, okay, but the results could actually be slightly better. So we can see that the number of steps have doubled. We can see that we have subset 0, subset 1, subset 2. We have 3 subsets, one for my first the subject, the second for my second subject, the third is for the regularization set. Now, regarding the regularization set, it will only use a limited number of images, which are 12 plus 14. Let's calculate it. 26 multiplied, okay, sorry, 12 multiplied by 10, that's 120, plus 14 images multiplied by 8. So that is 223. So it will only use 223 regularization images. We add to that 26, and it will give us 258. So what will be loaded in the cache is actually 258 images. That includes the 232 regularization images and the 26 images that we are training. So similarly, we will wait for the output and see, compare the regularization set and without using regularization. So we come after a while, after 20 minutes, for example, and check the resulting epochs, the output from each epoch. Okay, we can see that at epoch 1, it's learning the concept. This is not a mannequin. Having Asian faces, that's most likely because the classification set has more Asian faces. That's also possible, or because of the SD. We can see that at epoch 2, it's learning the pattern on another direction. Okay, better. Epoch 3, epoch 4 is better. Epoch 5, okay, that is on the right direction, but slightly different. Okay, we can see that at epoch 7, it's starting to change. Now, based on these results, this actually looks slightly better because it resembles the subject more. So we can see that the regularization was not a great success. It's acceptable. It produces good results in general, but the regularization set itself, okay, can affect the output and may not give us the exact results that we want. We will stop the training for now because I don't see any point, because right here we can see that the face is starting to look more like the mannequin, and we are starting to get extra things on the dress. So the maximum 4 from epoch 4 to 6 look acceptable. So we can test them further using stable diffusion in automatic 1111. Now for testing using automatic 1111, I often use basically the same prompt that exists here with slight modifications. Okay. So this is the prompt. We would then put the LoRA, which is XYZ Clothes version 1. Okay. We would use the same negative prompt. It's a very simple prompt, so it's fine. Put steps of 30, for example. We want full body shots, for instance, 768. Now we can change the prompt slightly. For example, young woman wearing blue XYZ dress, cowboy shot, looking in a simple background. We could also, for example, without simple background, in a street, for instance, in a street. So it's very important to do the comparison using XYZ plot. It's also very good to use After Detailer. What After Detailer does is that it fixes the faces. So it's automatic in paint. I've explained this in another video. So instead of a cowboy shot, I would use portrait. I can use the same LoRA or remove the LoRA and rely on the faces that exist in the stable diffusion itself. Looking at the viewer in a street, for instance. We don't want in a street because in the After Detailer, I just want the portrait. So I don't care about the dress at all. I just want a portrait of a young woman. So what we would do is go to XYZ, then do comparison between the epochs. For instance, I have this one. I want to compare it with epoch 4, for example, and epoch 5. Then I want to check the regularization reg, starting from epoch 4, for instance, then epoch 5, then epoch 6, for instance, then epoch 7, etc. Now it's also sometimes I start just with a couple of epochs. If I saw that, for example, I start with 3 and 4. If I saw that 4 is okay, I go to 5 because the testing can take some time. I also check regularization, for example, 4, 5, 6. Then if I saw that 6 is okay, I go to 7. And so on. Sometimes the results that we obtain using stable diffusion could be better than the results that we gain using the Kohya SS. Now, if we want to get the same results, we have to fix the seed using 1 because this is the seed that we have used in Kohya SS, but I don't want that because I want more flexibility in the model. Now, this is the comparison between the various epochs and the various models. Next, I want to check, for example, changing the colors. So I said that I have already left the blue inside the captions. The reason for this because I want to check if I can change the dress, for example. So I would change red. I will, for example, emphasize the red more. Then I want to, for example, change the model itself. So instead of XYZ, instead of the blue dress, I want to also include the blue jeans. So this is how XYZ comparison is performed. We choose, instead of the seed, we choose search and replace, search and replace, search and replace, and we define the rows, columns, and which models we want to test. Then we start running and see the outcome. Okay. Now I will run this in the background because this can take a little bit of, it can take a couple of minutes. But in general, if we want to check one test, for instance, we just put something like this and see the results for the epoch 3 of XYZ blue dress. We can see that from the first attempt, we have obtained a perfect result. Now, despite that this was actually a mannequin, now it is a real person or AI-generated real person. Okay, now I will go to test the XYZ and show you the final results immediately. Now I have generated different results. Initially, what I have tested is just a couple of epochs. So when I saw that the results were acceptable, even at epoch 4 without regularization and regularization, I started to increase the number of epochs, okay, and include more models in the tests. We can see here, for example, when we had a blue, in some cases it resembles the target, in some cases it does not, okay. So this is very normal stable diffusion. So we generate different images and pick the ones that we find to be better. Now, when we try to change the color, for example, we can see here that the color has changed. In some cases, it does not. In the case of dress, okay. In some cases, it generates extra things that we don't want. So we can see that when it comes to regularization, the change in color is better. Okay, but in terms of similarity, without regularization, it looks slightly better. Okay. When it comes to the jeans, when I try to change the color of the jeans, only the color of the shirt has changed. This means that it's ideally we should test the jeans in a different LoRA, okay, and see which results would actually produce these jeans with different colors. So it might be also related to prompting. In general, the results are really good. We can see another example. I added more epochs. This is epoch 5, for example. We can see that even at epoch 5 is still good. Now, Kohya SS in epoch 5, the results were a mannequin. However, with the random seeds or different prompting, the mannequin will disappear. Now, in this case, the mannequin has disappeared. Now, this was actually a mannequin. Okay. See, this is a mannequin. Now we have a real person or someone AI generated real person. Now the dress is really good. We can see that we have our dress trained properly. Now with the regularization, we can see that the results are also acceptable, good, but not always as good as without regularization in terms of similar resemblance. But in general, it's really good and more flexible. We might need to train more. Okay, this is an example in which a mannequin appeared. Okay, so a mannequin, depending on the seed that is generated, sometimes the mannequin appears. This is also related to the prompting. So when I saw this example appearing, so I changed the color of the hair. So I said, for example, brown hair and long hair. So the mannequin started to disappear from the generated images. Now we can see that regularization at epoch 6 is better than epoch 5 even, and it resembles the target more. We can see here, for example, when I prompted for a red, I included red in the prompt. Only the color of the shirt changed. We can see different types of shirts. On the other hand, with regularization, it becomes with regularization it's more flexible, but accuracy might not be always as good as we hope. Now this is a back shot from behind. Now my dataset does not contain any person from behind except for the genes. So this is something Stable Diffusion has deduced based on the learning patterns and has created a person with a back with this dress. Despite this dress does not exist, this image does not exist. Okay, so this is really advantageous and it shows that our model has learned the dress properly. Okay. Now, similarly, we can try different models, different shots. Now here I tested epoch 7. I saw that even with epoch 7, the model is still learning. So we might even test epoch 8 and 9 and 10 and still produces even better results than this epoch. But I did not want to spend so much time training and testing, but the principles remain the same. Now this is epoch 7 in a street, for example. We can see that this is this dress at epoch 7. It's really good. Okay. Now the genes remain the same, that only the shirt is being changed. Now with regularization, we can see that the patterns of the genes start to disappear in regularization. Without regularization, the patterns remain. So this means that with regularization, we need more training actually. So we might need to train up to epoch 10 or 15, etc., till we get something as we want it, because we don't want to have half patterns. We want to have the complete patterns. And regarding to the dress at epoch 7, so this means that this subject requires different number of steps and epochs than that subject. That is the point. This is why training different LoRAs is more appropriate than training different subjects inside to the same LoRA. Okay. In general, the results were really good. The LoRA was able to identify the clothes and change the person and remove the mannequin and became very flexible. Now these results are not selective, so I just generated a couple of samples and show all the generated samples. So I did not remove any defects or selected these seeds. So the first couple of seeds I obtained, these are the results. So the results are really great, and the same principles apply to all LoRA training of subjects. Have a good day.